Hey guys, so welcome back. In this video, we're trying to solve the problem 119 lead code, that is reverse bits. Okay, reverse the bits of a 32 bits unsigned integer. So the question is pretty straightforward. So we have a 32-bit integer, okay, but for our example case, I'll just be taking 8 bits, so it's a bit easier to understand. Okay, say for example, we have a number called 9. Okay, the binary of 9 is what? In 8-bit form. We'll have something like this, right? 1, 2, 3, 4, 5, 6, 7, 8. This is the binary of 9 in 8-bit form, right? Now you have to reverse the bits. So your answer should be 1, 0, 0, 1, 0, 0, 0, 0, right? This should be your answer, right? So how do you do this exactly? The first thing we do is we can keep a variable called result, okay? The initial value of result will be equal to 0. Now zeros, binary form is all zeros, right? So you just get 0, 0, 0, 0, 0, 0, 0, 0, right? So what you have to basically do is add the last digit of your number to the last digit of your result and just left shift and right shift. So I'll say what I mean by that. So you just do result is equal to result or of num and 1. This num and 1 will give you the last digit of num, right? And this result or will basically add to the result. So result or num and 1 will just add the last digit of num with the last digit of result, right? So after this particular operation, what's going to happen? After this particular operation, your result will be 0, 0, 0, 0, 0, 0, 0, 1. Right. Then we will right shift num and we'll left shift our result. So when we'll right shift our num, when we'll right shift a num, what will we get? 0, 0, 0, 0, 0, 1, 0, 0, right? 1, 0, 0. Now when we left shift our result, what will we get? Just left shift. So 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. We'll get this, right? Now we again perform the same operation. Result is equal to result or num and 1. Again, here it is 0. So 0 and 0 is same. We'll again keep doing the same operation. So in the next case, we'll again right shift num. So when we'll right shift num, we'll get 1, 2, 3, 4, 5, 6, 1, 0. Right? When we left shift result, we'll get 0, 0, 0, 0, 0, 1, 0, 0. Right. Again, add this one. Add the 0 of num to the 0 of the result. Again, when you keep on doing this, at the end, your answer will basically be 1, 0, 0, 1, 0, 0, 0, 0. In the case of 8-bit, right? In the case of 32-bit, you'll have like so many extra zeros over here, right? So that's the basic idea as to how to solve this. So now let's try and code the solution out. So as I said, we'll have a variable called result. So I'll just do res equal to 0. Now we have to do it for 32 bits. So for I in range 32, I'll left shift result, and I will perform the operation res is equal to res of or num, okay, n and 1, right? Then I will right shift num, right? That's basically it. I can return res as the output. All right, let's see as if this works. It works. Let's submit. And there you go. That's how you solve this problem. If you guys have any doubts, do leave them in the comment section down below. And that's it for this video. Don't forget to like and subscribe, and I'll see you in the next one. Bye.